There's a starman waiting in the sky. He'd like to come and meet us, but he thinks he'd blow our minds. There's a starman waiting in the sky. Okay. Happy was it Easter? Happy Easter, guys. Easter Sunday. I'm making this video Easter Sunday. Um, was it April 5th? So this is interesting. What was it, April 1st, on April Fool's Day? They fooled the whole world and making people believe in that we're going back to the moon. We're going back to the moon. They got everyone believing that we're going back to the moon using a rocket, going back to the moon. Well, why haven't we been back to the moon? It took them what, 60 years? Like a whole lifetime to go back to the moon. And I'll tell you what, it was an April Fool's Day joke, people. You took it too serious. It was April Fool's Day joke. And you guys literally went right over your heads. You have obviously no clue what the heck's going on because first off, it was April 1st, people. Happy New Year. It was April 1st, which is the first day of the new year. Why? Because I'm explaining it to you for the thousandth time. They ruined our calendar. The Romans ruined the calendar and added July with the Julius Caesar nonsense. October is 8th month of the year. November is the ninth month of the year. December is the 10th month of the year. The 11th month of the year is January, my birthday. The 12th month of the year is February. The 13th month of the year is March, meaning April 1st. April Fool's Day is the first day of the new year. Because why? Because there's only 4 weeks in 1 month, 1 month, and the 28-day uh, lunar cycle of the moon, which is 28 days. We got 4 weeks, 7 days in a week, 7, 14, 20, 21, 28, 28-day months with, so you take 365 divided by 13 months, and that equals 28 days, like I've showed you before, in 4 weeks every month. They're like, oh no, March, and there's 5 weeks in March, and there's 3 weeks, and it's like, no, there are 4 weeks, 28 days in every month. Every month is the same. There's no such thing as a 30-day month, a, February, which is our real month, a 28-day month. There's no such thing as a 31-day month. January is a fraud. My birthday is a fraud, okay? Because there's only 28 days in a month, people. But whatever. Happy New Year's. Glad you guys are here. Um, this is gonna be a quick one. I'm just gonna discuss what I know about some things. And I know people don't like to work hard anymore, so I'm going to do all the hard work for you. So let's see. I had to use two different web browsers because the stupid scams on the internet have been going on. One of my web browsers don't work. Okay, so I'm going to explain to you something. So you look up at the sky and the sky is blue, right? And a lot of people have no clue why the sky is blue. They tell you, "Oh, it's because of the microwave radiation from the sun and the the refraction and the angle of the light going through the air, and we're living in a prism and all this weird stuff." I'm like, it's much simpler than that, people. Like, where does water come from? Water comes from the sky. When you look at the ocean, what color is the ocean? Blue. So water comes from the sky, and the ocean's blue, and the birds fly, and the trees blow in the wind. Everyone knows these things. So if you want to know why the sky is blue, I'll explain it to you. So when it rains, the water comes from the sky. Like, you have a cup, right? And you fill the cup full of cold water. Well, because of the moisture in the air, the water condenses on the cup because of the cool temperature of the cup. Now, if you boil that cup or make it hot, you're not going to have the water condense on the cup. It's going to do the opposite. So The reason why it rains, like, you don't have to be a meteorologist to know this. I bet even a 6-year-old can understand that when it rains and the air gets cooler during every storm is because the moisture in the water in the air condenses because of the cool temperature, and it forms rain. And the rain falls from the sky when there's what? Lightning, static electricity, because the water particles are floating in the air. They're heavy. Water particles are heavier than air particles, but the reason why water particles can float in the air, the moisture of the water particles in the fog floating in the air, is because they are statically charged. And we are living in Earth's magnetic field. So they are statically charged, just like a feather floating around in the air, static, electrostatically charged, allowing it to float in the air. It's called anti-gravity or field propulsion, whatever you want to call it. That's just the basics of how I can explain it to people. So when it discharges and it it rotates the electromagnetic, the electrostatic. Like, you ever notice? I said this before. You put your dryers in the dryer and you pull them out, and they're sticking to you, and then it's nice and warm, and once it cools down, it no longer sticks to you, and it doesn't have the static electricity anymore when you run your finger across the bed sheets out of the warm, and they cool down and they lose their static charge. Well, all of nature works the same way. The static charge in the air, when it discharges to Earth's ground in what's called lightning, uh, those particles of water lose their charge. They condense because the cool air, the air up high is cooler than the air down below on the ground, the surface, and so those water particles fall to the ground. And when the sun comes out and shines light across those water particles, the water particles dry up, they heat up, they dry up, they become electrostatically charged again, and they go back into the air. So water particles are heavier than air particles, but yet they go up in the air because they are statically charged, okay? And the air particles are down here, okay, people? The air particles are down here. So you see UFOs flying in the sky and all these crazy craft. Well, it's all electrostatics, people. Electrostatics using the Earth's magnetic field. You know, I'm trying to think of some other examples that I know, like the moon. You're like, oh, the moon is a rock. It's cheese, and the sun is it's a portal. They got all these crazy things, but if the moon's a rock, how come the moon don't fall down? You know, if it's a ball of cheese, why doesn't it melt and fall to the earth? I'm going to explain to you. It's because, first off, the sun and moon are not what you think they are, okay? Um, and all energy in our place comes from the sun, okay? Everything comes from the sun, and it gets projected down here like a motion picture, a movie, like a projector. It all gets projected down here, and then the plants absorb the water particles and grow, and then the plants turn into food, and then the animals eat the food, and then the animals die, and everything turns back into a mineral, into the ground, and it's a constant circle of life, constantly getting sent to the sun, the water evaporating, the blood, everything getting sent back to the sun, and then it comes back from the sun and gets recreated down here. It's the cycle of life. The moon is nothing other than a reflection of the earth. Saying you're going to land on the moon is like saying you're going to land on a rainbow. Okay, and I don't know anyone that can land on a rainbow. Where they say, "Oh, there's a pot of gold at the end of the rainbow." The reason why they tell you that is because the closer you get to the rainbow, the farther away it moves away from you. So you can't get to the end of a rainbow. It's not physically possible, people. Same reason why you can't land on the moon, because the closer you get, the farther it moves away from you. It's not physically possible, okay? And it's not a rock floating around up there like a flying UFO, it's a reflection. It's looking at the moon is no different than looking at a rainbow being projected from the sun. So, it's a reflection of the surface of the earth. And what is it reflecting on? let's do some physics for you and a little bit of mathematics since no one else wants to do the work. So in aviation, all you aviators out there know, in fact, things have changed. I don't know if the AI changed or what, but when I was in school, I don't know what that was. When I was in school, I was taught that every 1,000 feet, the temperature decreases by 1 degree Fahrenheit for every 1,000 foot in altitude you go up. Well, apparently, according to the AI, I am wrong, and the temperature actually drops 3 to 5 degrees per 1,000 feet you go up in altitude. Wow, that just feels not correct, but let's go by what science is telling us, okay? Um, so if the temperature drops as you go up, let's say you're flying at 35,000 feet in a jet airliner and you open a window. Well, because you lose 3 to 5 degrees for 35,000 feet, let's do 35,000 feet. So that would be 35 times 3. 105. So that means the temperature at 35,000 feet apparently is about 100 degrees cooler than the temperature down here. And I don't know about you guys, but if it's 90 degrees down here, that means at 35,000 feet, it's probably like 4 degrees, 2 degrees up there. And that's only at 35,000 feet. That's pretty cold, okay? Now, let's go higher than 35,000 feet. Let's go to 60 and 80,000 feet, okay? So let's go 80,000 feet. That would be like the U-2 bomber, where you got to wear this astronaut suit and everything to fly at 80,000 feet. So that would be 80 times 3. So at 80,000 feet, it's 240 degrees colder than it is at sea level at the surface of the Earth, which, let's say on a nice hot summer day, it's 90 degrees out, okay? You take 90 degrees minus 240 degrees. Let's do that. 90 degrees minus 240. So it's negative 150 degrees at 80,000 feet. Now, I don't know about you guys, but I'm pretty sure that's below freezing, okay? And that's only at 80,000 feet. That's like the highest flying aircraft we have. That's like the SR-72 Blackbird, the Aurora aircraft, the U-2 bomber, probably B-2s. Maybe a B-2 can fly up at 80,000 feet. Probably, I don't know. And so that's kind of low, right? I mean, if you go up to 80,000 feet, I don't think the sun and moon is at 80,000 feet, right? Nobody knows. And anyone that tells you they don't know, and I'm proving it right now. And this is just basic math that probably a second grader can do, or a third grader, or whatever. So, I'm going to ask the question. I asked the AI, so there's oxygen in the atmosphere, okay? And so I asked it, what temp does oxygen turn to a solid? What temp does the oxygen in the air turn into a solid? It says solid oxygen is extremely cold, freezing at 54.36 Kelvin or negative 218.79 degrees Celsius or 361.82 degrees Fahrenheit. Negative 361 degrees Fahrenheit. So based off my math, let's do 361 divided by, and I don't think it's 3 degrees per 1,000 feet. I think it's 2 degrees per 1,000 feet. So I'm going to go divided by 2. So 180. That means at roughly 180,000 feet off of the ground, 180,000 feet in the air, you have uh, frozen oxygen. Frozen oxygen at 180,000 feet. That's over twice the altitude that our most advanced military aircraft and rockets can fly at, people. 180,000 feet. Okay? And I'm just giving it the best of the doubts, you know. Apparently according to the AI, it's even worse than that, okay? So let's go back to where I was saying. What temp does oxygen turn? Yeah, negative 361 degrees Fahrenheit. And it says right here, it is a light blue, crystalline solid that exists in multiple phases depending on temperature and pressure, remaining solid at any temperature below its melting point. this melting point such as liquid helium. So right here, appearance, light sky blue, similar to a table salt crystal as shown. Okay, so if the sky is blue, and at the altitudes we think that that is 200,000 feet off the ground, uh, oxygen in the air, the thin air, oxygen and the molecules in the air turns into a solid at those temperatures. Because I just mathematically showed you, uh, scientifically showed you the science behind why the sky is blue, people. That's why the sky is blue. Because I told you it's ice, it's frozen oxygen. Okay? Because the air is so thin up there because of the pressures, the temperature, like I said, lose 1 to 3 degrees every 1,000 feet in altitude you go up in the air. So the sky is blue because the sky is a snow globe. It's frozen solid ice, okay? And within that frozen solid ice, we have the sun and moon. So looking at that, I'm not saying the sun and moon's at 200,000 feet, and I'm not saying that the firmament that's talked about in the Bible is at 200,000 feet. I think the science is wrong. I think the math is wrong. I think the AI is wrong. I think it's much higher than that. I think the edge of the universe is at 400,000 feet altitude, realistically. And I think the sun and moon is realistically at 200,000 feet because I just proved it to you using the math. I proved it to you using barometric data, barometric sensors, and flight characteristics of aircraft is what I'm taught in school. Okay, um, so yeah, that's the firmament, people. And like you could do the math. I just did it for you, but you could do it yourself if you don't believe me. I mean, it's right here. Read it. Standard temperature lapse rate is decreases approximately 3.5 degrees to 3.6 degrees every 1,000 feet of elevation gain. And how do you know this? I don't know. Go climb a mountain. Is it warm at the top of a mountain? No. And the higher you go, the colder it gets. Okay. So when you get up there, and that's another thing. There's not a whole lot of oxygen even left up there too. You need like to fly at 80,000 feet, they need oxygen bottles because the air is so thin. You can't even breathe the pressure and the temperature, dude. The temperature is well below freezing. So cold that the air turns to ice. So cold that when we have a storm, the ice falls out of the sky. The hail, the ice falls, the snow falls out of the sky because up drafts and low drafts. I mean, it's all about meteorology and study of weather and stuff, but I know enough to know uh if I'm being fooled or not, you know. So when you look at April Fools, they're going to the moon. Okay, yeah, go land on the rainbow. Go bring us that pot of gold. Tell us how nice that pot of gold is. Now I'm gonna let you in on a little secret just because it's Easter Sunday. First off, my rocket parachute idea, you know, they launch these rockets up there. It so happens that NASA's the number one user of helium. Oh, I wonder what that is. You know, helium. Why do they need helium? Well, you need it to make gondolas. You know, so when you're launching all these rockets up there, they're exactly like these little parachute fireworks that you launch up in the air, and the parachute it blows up, and the parachute comes out of the rocket and falls to the ground. Well, the rockets that they're using are not little parachute rockets. The rockets they're using have what's called gondolas, which are helium balloons with satellites tied to them. So when you're like, why are the satellites going in 15 different thousand directions and not hit each other? Well, they're all tied to balloons. And the reason why they go those directions is because that's the directions of the wind currents. Because when you get up to that altitude where the air is super thin, the air moves much quicker. Like you have 300 mile an hour winds at 100,000 feet. Okay. So the satellites and stuff, the gondolas with the helium balloons, they get blown all over the place up there, you know? And so you're like, why are they launching? If it's all fake, why are they launching so many rockets? Well, now you know why. They're launching gondolas for satellites so you have internet in the Middle East in the desert. So since it's Easter Sunday, I'm gonna close it out with the Son of God. You know, and I know I'm not talking about this Son. I'm talking about Jesus Christ, who who came here and died for us. You know, people don't understand these things, you know. It's the new year. Spring starts in the new year, April 1st. uh, the the flowers are blooming, the trees and leaves are coming out on the trees. Winter's over. Um, but we got the sun. You know, that God gave us the sun for our food and harvest. And when I ask you to draw a picture of a sun, are you just gonna like draw a circle on a piece of paper and say that's the sun? Well, according to NASA, that's the sun. It's just like a little dot circle on a piece of paper. Okay. But that's not the sun. You know, when they ask you to draw a picture of the sun, it usually looks like this. You know, you see the rays of light like triangles put together. You know, the rays of light come out at all these different angles. Now I'm going to end it with this. Since it's Easter Sunday, when you guys look at the sun and you see all the rays of light coming out at different angles, I want you to go look at the moon, especially on a cloudy night or a partly cloudy or a foggy night, and look at the moon and tell me what you see. Okay? And if that doesn't wake you up, then I can't help you. Sorry, I did my best. What you're going to see is looking at the moon on a foggy, cloudy night. You're going to see this. You're going to see the cross. You know, the Christian cross. The rays of light that come off of the moon is not like the sun. The sun, the rays of light come out in all these multi different directions. But the rays of the light uh, from the moon, the reflection off a full moon, the rays of light come, they look at you like a cross. So when you're looking up at the moon at night, and if you're paying attention, most people don't even look at the sky anymore. If you're paying attention on a full moon night, which is beginning or end of the month, full moon night, you will see the Christian cross in the sky of the moon. And I tried to take a picture of it the other night, but my camera didn't work. But yeah, that's what I know, guys, and I hope you guys take this serious or don't. I don't really care. It is what it is. But I hope you guys have a happy Easter and happy New Year. If you know, you know. Adios.